So we've now established that for Padraig to get his 20,000, his pension of 20,000 per year for 25 years, he needs to have in the bank the sum of 358710.84. Now I think they may have said to the nearest euro, so that would be 711. I'm not too worried about that. Okay. Now, in the next part of the question, we're going to need to figure out what exactly he needs to put away starting from now so that he has this at a particular time so that he can start donating when he retires, basically, so that he can start giving himself these payments of 20,000. Okay, so the first part of the question is, Padraig plans to invest a fixed amount of money every month in order to generate the fund that he wanted, okay? His retirement is 480 months away. So the first thing is, he's going to put it away every month. So they're going to ask you now, what is the monthly equivalent rate? Okay, so an annual equivalent rate of 3%, what's the monthly equivalent rate of that? So again, how do you do that? If you put a certain amount away, and you know that at the end of a year, you get 1.03, okay, you want to know now, 1.03 times P, because that is at 3% per year. So you're going to get P plus 3%. Then if you were to put that away instead and get compound interest every month instead of every year, what would be the equivalent interest rate that you would be given in order to come out with the same amount at the end? Okay, so what we're saying here is this is P. At the end of 12 months, we will have P times 1 plus I to the power of 12. We want P times 1 plus I to the power of 12 to be equal to 1.03 P. Okay, so divide both sides by P. 1 plus I to the power of 12 is equal to 1.03. I will be, 1 plus I, if we take the 12th root, is 1.03 to the power of 1/12. I is 1.03 to the power of 1/12 minus 1, which turns out to be 0.002466. Now, that is the interest rate as a decimal. The interest rate as a percentage is 0.2466%. Okay, so that's the answer. So the monthly equivalent rate of 3% per year is 0.2466%. The next bit says write down, write down in terms of P the value on the retirement date of a payment of P made n months before the retirement. So you want to know if this is the date, the retirement date here. You want to know what is the value on the retirement date of a payment of P that has been put in n months before. So if this has been put in n months, then every month it is multiplied by 1 plus, in this case your interest was 0.0, your interest rate 0.02466. Every month you're going to get P is going to be multiplied by 1.002466 because every month you're adding on that much interest, that percentage, or 0.2466% of interest. So for n months, at the end of n months, you're going to have P times 1.002466 to the power of n. Hopefully you'll see that. So that's that piece. Now, the next part. This is where it's all going to come together. If Padraig wants to make 480 equal payments of P from now until his retirement, so he basically wants to make P, 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 480 of them from now to the end of now. Now I'm taking it the fact that it says from now. It's not very clear here, but from now. So I'm assuming that the first P is paid straight away here. Okay, and basically I'm taking that as being the start of the month. Okay, so the very last P I'm assuming then is here at the last, just at the start of the last time frame. Okay, what value of P will give him the fund that he wants? So this is the fund that he wants, calculated from the first part. We need to look at the future values of all of these P's. This P in 1 month's time is worth P times 1 plus or 1.002466. The P before that will be P times 1.002466 to the power of 2, because it'll have been in for 2 months, all the way back to the very first month, or the very first payment, which has now been in there for n years, so it's worth P times 1.002466 to the power of n, because it's been in for n time frames, n months actually. So we want the sum of this to be equal to this. So he's collecting all his future values at the one time right here, and they need to sum up to give us this. So this is a geometric series. The A of the geometric series is P times 1.002466. The R, the common ratio, is 1.00246. That's what you're multiplying by each time. And the Sn is going to be what your 35870 is. Your Sn is A times 1 minus R to the power of n over 1 minus R, which is P times, now, 1.002466. That's your A, times 1 minus R to the power of n, and n is 480 months, over 1 minus R. Okay, now we want that value, that sum, to be equal to 358,710.24. Okay, and we need the P for that. We need to figure out what does P have to be. So basically, hopefully you can see that P, multiply both sides by that. P is 358,710.24 multiplied by 1 minus 1.002466 and divided by 1.00246 times 1 minus 1.00246 to the power of 480. Okay, and when you put that into the calculator, you get 390.17, I think I got. Okay, now the very last part of the question, I'm running out of time here and I'm conscious that my video won't upload. That's the answer. So that's how many regular payments he needs to pay, or sorry, that's the regular payments, 390.17. If he makes those every month for 480 months, he will end up with that money in the bank at the end of the 480 months, and then that will allow him to get the regular payments of 20,000 a year. The last part of the question just asks, if he doesn't start for another 10 years, what would his payments have to be? So the only change there is that if he doesn't start for 10 years, that's 120 months later. He needs to now do all of these payments in 360. 480 take away 120. So he now only has 360 months to get his payments. 360 payments to sum up to that for their future values. So basically you just change this number to 360. And obviously he'll get a larger number. When you change that number to 360, you get 618.35. Okay.